So now we basically take this process, we're still solving inequalities, but now what we have are rational functions. So the only thing that's going to change here, step one is still the same. We're going to find out what makes us equal to, but we also have to make sure we figure out what makes us undefined. All right, and then we lay that on the number line, test our intervals, see which ones satisfy the inequality or not, and then we're off to the races. All right, so for looking at this first one, right away that I can see that x cannot be equal to 5, right? So that's kind of easy. So we already have what makes us undefined. What makes us equal to 0? Well, you can either set it equal to each other, or if you recall from previous work last week, our zeros, right, our x-intercepts are basically coming from the top. So again, I can kind of see x equals -1 right off the bat. But, you know, officially doing it, if I multiply both sides by x minus 5, we basically get x plus 1 equals 0, and it is exactly what I said. So x-intercepts are occurring up in the numerator, undefinitions are occurring down in the denominator. All right, so I'm going to use that to my advantage. So there's my two values. So we're going to go to our number line. We've got -1, and I'm allowed to be equal to it, right, because we're allowed equality. And then we basically have +5 somewhere down the line, but we're not allowed to be equal. So we have an open circle at that one because we know graphically we would have a vertical asymptote there, and here we have an x-intercept. Right? So there's basically my intervals. So I just did step 2. Step 3 is to start testing those intervals. What makes us, what makes this situation true? So what's to the left of -1? There's a lot of values. How about we try -2? So a -2 plus 1 gives us -1, right? -2 minus 5 gives us a -7. This gives us a 1/7, and this, right, is actually greater than 0, so we're positive on that interval. We're not less than 0. The next interval, there's a lot of things between -1 and 5. The best choice here is x equals 0. When I plug it into the top, we get 1. When I plug it into the bottom, we get -5. And in my book, that is in fact less than 0, so we are negative on that pattern. Okay? Over here, we got x equals 6, or anything else you want to throw in there. 6 plus 1 is 7. 6 minus 5 is 1. And I don't know about you, but 7/1 is greater than 0, so we are positive. All right, and so solving this, there's basically I just did step 4, if you would, right, by taking a look at what's analyzing this. So we're basically on this interval right there, right, because we want to be less than 0 or equal to it. So step 5 is to write our answer. So what do we have? Well, it looks like we have -1, and we're including it all the way up to 5, but we're not including it. So this graph is below the x-axis. So the function's above, it's below, and it's above, right, on the interval from -1 to 5. So that's what our algebra is telling us. Of course, to check that, let's go to Desmos. If I go graph this function, right, we can see, let me come back out here a little bit, that in fact we can see from -1, right, so let me kind of come back in here. So it's crossing the x-axis at -1, and then up to 5, notice that the graph is below the x-axis. And then we zoom out. Past -1, it's above, it's positive, and past 5 over here in this region, it's also positive. So that graph kind of matches. In this region, we're above the x-axis, we're crossing the x-axis, we're below the x-axis, we are an asymptote, right, and then we go through a sign change. So we can verify that from -1 including it up to 5 excluding it, the graph is basically satisfying the inequality less than or equal to 0. So our graph matches our algebra, which should happen. All right. So let's do the next one real quickly. I think I have time to do that. So looking at this one, again, I can see we have some undefinitions. If I factor everything, my undefinitions are x cannot be equal plus or minus 4. And then taking our cue from up here, I know I'm equal to 0 when x is equal to 2. All right, and so here's when I'm equal to 0, and here's where we're undefined. So I take those values and I put them on a number line. So somewhere way over here is -4. We have +2, and we have +4. So here's what makes us equal to, and here we can't be equal to. And since we have a strict inequality, it doesn't really matter if I'm equal to or not. We're going to have open circles around each one of those things because of the strict inequality. And then, of course, we have an interval to the left of -4, an interval between -4 and 2, an interval between 2 and 4, an interval past 4. So we have a lot of work to do for our step 2 and 3. So how about we let x equal -5. Again, -5 minus 2 is a -7. And then -5 squared plus 16, well, that's 25 minus 16, excuse me, which is 9. Net effect is we're less than 0, so we are negative on that portion. -4 and 2, x equals 0 is available. It's always nice to use. Putting a 0 in here, I basically get a -2, and putting a 0 down wherever you want, we get -16. Well, negative times divided by a negative is a positive, reducing, that's greater than 0, so we're positive. 2 and 4, well, what's between those two is 3. So 3 minus 2 is a positive 1. 3 squared minus 16 is a -9. That's less than 0, so we are now negative. Past 4, if we let x equal 5, right, 5 minus 2 is 3. 5 squared minus 16 is going to give us 9 again, which reduces to 1/3, but more importantly, it is positive, so we are positive. So, after analyzing our x-axis, it looks like, where are we positive? Well, it looks like we're positive between -4 and 2, and it looks like we're positive past +4. So, writing my answer, this interval is -4 to 2, and this interval is 4 to infinity. So, on that stretch, our graph is above the x-axis, and on that stretch, our graph is above the x-axis. And just to verify that, let me go to my Desmos calculator again. Let me turn that last function on and turn that one on, and you can see, right, that this kind of verifies what we're doing. So right there is -4, so we have an asymptote. We're not allowed to be equal to that. And then right here, 1, 2, there's 2. So between -4 and 2, the graph is above the x-axis, just like I predicted. So f of x is greater than 0. And then at again, that's 4. We have an asymptote because we're undefined, but more importantly, past 4, the graph is above. And then we can also see we're below, and we're below, right, on the intervals that we predicted. So again, my graphing verifies what we're seeing algebraically. All right, so I'm going to stop there because you can see what's happening in the next two. We're set equal to 0, so we're truly talking about positive and negative. But in this next one, we're not equal to, or less than or equal to 0, or greater than 0. So there's some nuances that are going to come into play. So how about I just cut to a new video? We'll do these next two in that next segment. But again, the step-by-step process. When am I equal? When am I undefined? What satisfies the inequality by testing it? And we go from there. So that's what you're going to see me do real shortly. Talk to you guys in the next video.